All right, so the first thing it says that the flagpole at the right angle to the horizontal is located on a slope. So if you start with the flagpole on the horizontal, it would have looked something like this. And by horizontal, it would be that it's 90 degrees, right? But then it says it's not on, like it's not, the ground is not flat there. There's a slope. That's 12 degrees. So you can go up on the right or you can go up on the left, like I could have done it there, or I could have done it here. But you got to do it one or the other. And that makes that 12 degrees would be the slope, or the angle from the, that's really bad horizontal, but you get the point. A horizontal with that slope. Then it says that the flagpole shadow is 16 meters long and points directly up the slope. So I know to go up the slope, and I know to make it 16 meters. And if there's a shadow on that side, it means the sun would be over here. And that's important because the last thing it says is the angle of elevation from the tip of the shadow to the sun is 20 degrees. So if I go tip of the shadow up to the sun, this angle is 20 degrees. So then this right angle includes that 12. If I subtract the 12 from the 90 degrees, I get 78, which is the angle inside the triangle. And then I've basically got a triangle here in which I know the two angles and the included side there. I could add the 20 and the 78, 98, and subtract that from the 180. I get 102. That's the top angle. And then I'm trying to find the height of the flagpole. So I would have done 16 over the sine of 102 equals x over the sine of 20. Cross multiply and divide from there. Question, any other questions? How about from WebAssign? Everybody was okay there too? Okay, great. So section 2 is law of cosines. This is the other method you can use to solve oblique triangles. Remember, they're going to get grouped in together, so you'd have to be able to look at the information given to determine which one to use. So when we got given angle, angle, side, or side, side, angle, we used law of sines. With law of cosines, you're going to see we're going to use side, 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 and side, angle, side. So the good part about law of cosines is there's no like catch. There's no one triangle, two triangle, no triangles. The hard part about law of cosines is the formulas. If you can memorize one of each of these, it's a pattern that just repeats. So that's your goal, I would say. For the standard form, which is the one that's used to find a side, it is a squared equals b squared plus c squared minus 2bc cosine a. B squared equals the other two sides squared. So a squared plus c squared minus 2ac cosine b. And the last one is c squared equals a squared plus b squared minus 2ab cosine c. So this is for your side angle side. I'm given two sides and the included angle. I get one of each letter, two sides and the included angle. It will be the one you're missing. So the one you're missing, like if you have two sides and then on it and the included angle, then you'll put the side you're missing on the outside. You'll find that last side, and then you can move on to the alternate form, which is going to give you the other angles. So this is used for side, side, side. If I know all three side lengths, then the cosine of A equals b squared plus c squared minus a squared over 2bc. So the side that matches the angle you're solving comes last. That's the one you minus. Okay, you square the other two, add them together, and then subtract the letter that matches the one you're trying to find. And then it goes over 2 times the first 2 letters again. Yep.
So the difference between side angle side and side angle is that it's like a side angle and then side.
Correct. And the side is literally going to be each lowercase letter.
Okay. And then a side angle would be like any 2 sides in an angle that's not connecting.
Correct. So these, I think I said it yesterday, but I'll say it again. Like if you're a Quizlet person, I have a Quizlet that has all the formulas put together. It's got the law of sines, which hopefully is not too hard, but it has the law of sines, it has the area, it has the law of cosines, and it has the area that we're going to see in law of cosines too.
For the alternate,
again, with like these is when I'm solving it, like if it's one of the standard forms, my answer is going to be a squared equals something. So that last step is going to be to square root both sides. And on the bottom, my answer is going to be cosine of A equals something. And so that last step is going to be to cosine -1, whatever it is. So that last step is either square root or cosine -1. Square root if you're finding the side, cosine -1 if you're finding the angle. You just have to be careful because people tend to write out this whole thing and forget this part, and then they give the answer as the cosine, which is wrong. Or they forget to put the squared on here, and they give the answer for whatever get there, and they forget to square root it. So those are silly mistakes that are made in this stuff. All right, so for a side angle, side triangle, the first thing you're going to do is find the missing side. So you're given 2 sides, you've got the angle, you're going to find the missing side first. And then if the angle given is obtuse, so if you start with an obtuse angle, you can actually switch to law of sines, or you can continue with law of cosines. If the given angle is acute, you're going to continue with law of cosines. So my advice is stick to law of cosines. It's the safer one, okay? But if you are given the original one is acute, you could create an ambiguous case that is actually not an ambiguous case, because then the information you're using is side angle, okay? And it's not like that is what's supposed to happen. You're using the information wrong. So the best bet with law of cosines is just stick to law of cosines the whole time. If you're going to switch, you can if the original angle is obtuse. And then once you get the first two angles, you just subtract it to get the third one. All right, so this says use the law of cosines to solve the triangle and round to 2 decimal places. So I've got side, angle, 1 of each letter. So this is side, angle, side. The first thing I'm going to do is look for the third side, which is A. So A squared equals B squared plus C squared minus 2BC cosine A.
What do you mean by 1 of each?
I have 1 of each letter. Like I have something for A, something for B, and something for C. Right? You see A, you see B, you see C.
So that's how you know it's side equals side?
If that's 2 sides and an angle. If it was 2 angles and a side, then it would be angle, side.
Okay.
Yeah.
And that would be law of sines?
Law of sines. Yep.
And in the quiz, would you tell us what
No.
so we can...
I mean, draw your triangle if you want, and if you have a complete ratio opposite each other, then you know to do law of sines.
Okay.
Yeah.
What do you mean by that?
Like if I have both the angle A and the side of A, I know I'm doing law of sines.
Oh.
Right? Because you have, right.
2 match. Oh. So if there's no 2 matching, then you do law.
Unless you can find that third angle, because that's, like we do where we know B, we know C, so we find A, and now we've got a complete ratio.
But then you can use law of sines, right?
That's law of sines.
But there wouldn't be a time that they're matching and you have to do law of cosines, right? Like the A and the A are matching? Like you have
No.
A and A.
No, correct.
Wouldn't do cosine?
Correct.
Okay.
Law of cosines is either side, angle, side, so you get 1 of each letter,
Okay.
2 sides and an angle, or it's side, side, so you know nothing about any of the angles.
Okay. So you would have A, B, C.
But one of those is capital.
Well, one of them is capital.
Yep.
Okay.
Or A, B, C, and all of them are lowercase.
Got it.
Yep. All right, so my formula for side A squared equals B squared plus C squared minus 2BC cosine A. And then I'm going to plug in all the information I have. So A squared equals 21 squared plus 42 squared minus 2 times 21 times 42 times the cosine of 39. So 21 squared plus 42 squared minus 2 times 21 times 42 times the cosine of 39. And I get A squared equals 834.114524. I'm not going to round it. I'm going to square root it. So you could have also done that from the beginning. And I get A equals 28.88. So I could have typed it in as this, the square root of all of that, and it would have gone straight to the answer. You could do it all in one step. You just got to be careful.
So you know that it's A squared because of the capital A.
Correct. Correct. Because you can't find anything else before you find that third side.
Like the A. Oh, okay, yeah.
Because in all the other cosine formulas, you need all three letters. So if you switch to law of sines, you can only do so if what you start with is an obtuse angle, and that's not an obtuse angle. So we stick to law of cosines.
How would you?
You can look. If it's obtuse, you can switch. If it's not obtuse, you stick. Which, again, my opinion, just stay. Law of cosines. Once you start law of cosines, stay law of cosines. So now I want to find the remaining angles. So let's say I say B. Cosine of B equals A squared plus C squared minus B squared over 2AC. So the letter that matches is the minus. So A squared would be what we just found, 28.88 squared, plus C squared, 42 squared, minus B squared, 21 squared, all over 2 times A, 28.88, times C, 42. And you'd cosine -1, that whole thing. So you can type all that in and then cosine -1 your answer, or you could literally cosine -1 from the beginning. How you do it is up to you. Here's the catch with cosine when you're finding the angle. If you type that in as is in your calculator, you are going to get an error because order of operations is going to square, square, square. But then before it does any of this multiplication, it's going to divide this by that. Because order of operations would say skip the adding, right, and go to the division, which is wrong. It's going to give you something that's bigger than 1. You're going to hit second cosine, you're going to get an error, and you're going to call me over to your desk and be like, something's wrong. And I'll be like, you didn't practice it, because if you practice this for the next 2 days, you're going to have done it so many times, you'll remember you have to put a parentheses at the front and at the end of your numerator and your denominator. You have to group them. So when you type that in the calculator, you have to put a parentheses here, 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 and then you don't really need it at the end because it's not necessary, but you need it at the beginning. So open my parentheses, 28.88 squared plus 42 squared minus 21 squared, close the parentheses, open, or divided by, open the parentheses, 2 times 28.88 times 42, enter, and I get cosine I get cosine of A is really what cosine of B is 0.889, so on and so forth. I'm not going to round that. I'm going to hit cosine -1, and I'm going to pull back the answer. And you should get angle B is 27.23 degrees. So I got side A, 28.88. Angle B, 27.23. The last one I need to find is angle C. Now there's 2 ways to do it. What's the easiest way? 180 minus 39 minus 27.23.
So even though you found those answers?
Cosines, you can't avoid it. Yeah. cosines, you're going to have to use what you find. What's another way to find that angle? You could.
How when it's not at 2?
Well, now you have both angles. So it only is based on that first angle. Like once you find the second angle, you're good.
Oh.
But what's another way? Good. I could do law of cosines, but for C. So I would do cosine of C equals A squared plus B squared minus C squared over 2AB. If you have extra time on your quiz, I would recommend doing both and checking. They might be off by like 100th because we're rounding, which is fine. But I would recommend checking if you have the time. Questions? All right, side, side, side is the other type of triangle we use law of cosines for. So if I have all 3 lowercase letters. Here's the most important part with side, side, side. You have to find the angle opposite the longest side first. So the order matters with law of cosines. Again, if you don't, you create a false, you could create a false second triangle that doesn't exist. So start with the largest side, which would be opposite, or sorry, the largest angle, which would be opposite the largest side. And then you can actually switch to law of sines, or you can continue with law of cosines. You could do either one. All right, so it says use the law of cosines to solve the triangle and round to 2 decimal places. So I've got A, B, C. Again, this is side, 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 all 3 lowercase letters. Which angle am I going to start with? C, because it is opposite the longest side. So I would say cosine of C equals A squared plus B squared minus C squared over 2AB. I'd get 11 squared plus 14 squared minus 20 squared over 2 times 11 times 14. And that's the cosine of C equals that. So you can do it all in one step if I do cosine -1, but I have to group together my numerator and my denominator. Oh, 105.63 degrees. Questions on that one? Yep.
For the 14 at the end, you have to put a second parenthesis.
You don't, because it's the ending one. All right, now it doesn't matter which order I go, right? I can go to either A or B, okay? But you have 2 options here. I can switch to law of sines because I now have C and angle C. Or I can stick to law of cosines. What's the benefit of one over the other? Yeah.
Could law of sines be shorter?
Could be, yeah. What's another reason we would choose one over the other? Let's set it up. If I use law of sines, I would get 20 over the sine of 105.63 equals B, which is 14, let's say, over the sine of B. That's just if we use B. If I use law of cosines, I would get the cosine of B equals A squared plus C squared minus 14 squared over 2, 11, 20. Which is going to be more accurate? Why?
Because the first one's wrong.
Exactly. Everybody see that? So if you switch to law of sines, which you can, but you will, like, if you go to check your answers on, like that, if you use the graphing calculator app and you put your answers in, they might be a little bit off if you've switched to law of sines. I'll allow both. So when I go to, like, grade the key, I'll give you both answers because it could be a 100th off or a 200th off. But the more accurate way would just be to stick to law of cosines. So in both cases, side, 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 and side angle side, it is more accurate to stick to law of, well, you have to use law of cosines all the way through on the first one if you don't do it in the right order. But this one, again, even if you find the longest one first, it's more accurate to stick to law of cosines. So then I would get cosine -1, and again, I would do this whole thing. 11 squared plus 20 squared minus 14 squared. Close the parentheses. Divided by, open the parentheses again. And I get angle B is 42.38 degrees. Last one I need to find is angle A, and for that I can do 180 minus 105.63 minus 42.38, or I can do law of cosines again. It would actually be a more accurate answer, but I will give both. Questions on side, side, side. So importance there is the order in which you do it in. It has to be longest first. If you're going to switch, if you stick to law of cosines the whole time, it won't matter.
Longest means like the biggest one.
Correct. All right. And you get some application of that one. It says find the angle theta between the two paces for both the carnivore and the herbivore. So it just gives you a diagram. On the left-hand side is the footprints of a carnivore. On the right-hand side are the footprints of the herbivore. In both of these cases, I'm given all three sides. So if I want to find the angle opposite it, I cannot use law of sines. So this should be a good indication, like, of what a word problem could look like. And you're like, I don't know which one to use. If I'm given all three sides, I'm going to use law of cosines. So I'm going to find theta. I can call it A. If you want to label them so that they're less confusing, you can totally do that. I would get the cosine of A equals, it would be B squared plus C squared minus A squared over 2A, or BC, sorry. So cosine of A would equal 2.9 squared plus 3 squared. Order there doesn't matter, but it does, you do have to subtract the 5.78. 2 times 2.9 times 3. So I'm going to inverse cosine that whole thing. 2.9 squared plus 3 squared minus 5.78 squared. Close the parentheses. Divided by, open the parentheses again. 2 times 2.9 times 3. And I get angle A is 156.85 because it didn't give me something to round to, so I do 2 decimal places. And then I'm going to repeat that whole process for the second triangle. So I can call it A again. This would be A. This could be B. This could be C. Cosine of A equals B squared plus C squared minus A squared. More times you write it, the more likely you're going to remember it. So I'd write it every time. I would get cosine -1 of the whole thing. So 3.6 squared plus 3.2 squared minus 5.2 squared over 2 times 3.6 times 3.2. And angle A is 99.59 degrees. Oh, Brandon. So if you would like analyze this, this tells you that the angle is smaller between the herbivore than the carnivore. What does that tell you? Think about when you're walking and you're next to somebody that's taller or shorter than you. What's it tell you? They're bigger, right? The bigger of the steps in between, right? It's a bigger carnivore than it is an herbivore. All right, this one says, you're on island B. What bearing should you navigate to go to island C? Does yours have the values on it? That's 16, 22. Okay, good. I know at some point it didn't. So if I'm on island B and I want to go to island C, remember there's 3 parts to the bearings. The first is north-south. So if I'm starting at B and I need to go to C, which way am I going, north or south? North. And then am I going east or west? West, good. Now I got to figure out this angle in here. How do I do that? I got to figure out the angle that's between my y-axis, because that's where the bearing goes, right? Between the y-axis and where the direction I'm heading. This, I have to figure out what that is.
The total would be 90, right?
Good. This whole thing here would be 90. Is that what you meant by total? Yep.
Isn't it side, side, side? So,
It is side, side, side.
wait, you find it?
Find what?
Like, find the inside?
Find this one
Yeah.
and then subtract it from 90 degrees. Good. So I'm gonna call it B because it's island B. We would say the cosine of B equals, this is gonna be, let me make these darker. This is B, this is A, this is C. So cosine of B is A squared plus C squared minus B squared over 2AC. And I get cosine -1 of 22 squared plus 23 squared minus 16 squared over 2 times 22 times 23. God bless you. So angle B is 41.58 degrees. But that's the inside angle, 41.58. So the last thing we have to do there is what? Good. Subtract it from 90.
Oh, yeah.
Yeah. So that the whole answer there would be north 48.42 degrees west. So like if you're ever lost out at sea and they don't know how to come find you, you could be like, I know how to figure this out because I know the distance from that island to that island. And then you're like, Miss Chris Weiser, I did use this in real life, right? Yeah. Just start tracking like the distance from all the islands when you're out on the boat in the middle of the ocean. Not a problem. And then you've got your calculator, your phone could do it. You just would have to know your formulas, which is why I'm going to make you know. All right, here's the last but easy part. Heron's area formula is the second way to find the area of a triangle. And this would be if you're given all 3 side lengths. So if I had side angle side, I use the first formula, the area of the oblique that we had that involved sine. This does not involve law of cosines, but it is the side, side, side. So the area equals the square root of S times S minus A times S minus B times S minus C. And the first thing you find is S by adding all 3 sides and dividing by 2. So it is not the average. We divide by 2. And we do not round S. So if it's got 3 decimal places, you keep 3 decimal places. It will always terminate. Could be 2 decimal places, 3, but you do not round it.
So, I don't get the difference between them. Like, when do you use it?
When do you use this one over what we used in 6-1? Or
Well,
both? You need both of these. So if you're given all 3 side lengths, then you're going to use Heron's formula. You first find S, and then you plug it into this.
What's S?
You have to find it. A plus B plus C divided by 2. Then you plug it into the formula.
Okay. And then when do you use this one?
The other one is, so this is side, 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 right? And then area of oblique is side, angle, side.
What about angle side to side?
You'd have to find other pieces of information. So I'm going to write it at the top. S equals A plus B plus C over 2. And then A equals the square root of S times S minus A times S minus B times S minus C. A is 5, 7, and 10. So the first thing I'm going to find is S. 5 plus 7 plus 10 divided by 2. This one's easier. It's 22 divided by 2, which is 11. So then the area is the square root of 11 times 11 minus 5 times 11 minus 7 times 11 minus 10. You can either simplify that, like do 11 times 6 times 4 times 1, or you could literally type that whole thing in the calculator because you've got it in front of you when you're doing this anyways. So second square root, 11 times 11 minus 5 times 11 minus 7 times 11 minus 10. And I get 16.24. 8, so 25. And again, it didn't give me a unit, so I would make it just unit squared.
We do have to write units.
No, I mean, it doesn't make it wrong if you don't have it. All right, B is just a little bit more complicated because it involves the decimals. So I would add these 3, divide by 2, 3.05 plus 0.75 plus 2.45 divided by 2. And S is 3.12. So my area is 3.12 times 3.125, sorry, minus 3.05, 3.125 minus 0.75, 3.125 minus 2.45. And it's 0.612, so it's 0.61. I would say just be really careful. Like this is one of those go slow to go fast types because the slow and careful typing in is going to get you the right answer the first time. If you're careless or you're rushing or you're stressing yourself out, you could type an answer wrong. Maybe check these again. Maybe type them in twice just to make sure that you don't make a silly mistake. Questions on law of cosines? All right. I almost hate to do it because I would love to see if those of you that remember your properties of parallelogram could pull this off without the help, but more of you are going to ask a question than not, so I figure I'll just get you started on these. So this is question 4, like the values are obviously going to change, but it says complete the table by solving the parallelogram shown in the figure. The lengths of the diagonals are given by C and D, so every single year somebody thinks that this is C because it looks like it's placed in the middle of that, but the directions tell you that C is the whole diagonal, okay? And then D is this whole diagonal. So even though it looks like it's only on half of it, it is the whole thing. It says round your answers, blah, 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 blah. But you need to know your properties of parallelograms. So what do we know about parallelograms? What do you remember about them?
Oh, their sides, like the...
Okay, the words you're trying to say because see it. Opposite sides are congruent.
No, I was going to say that they're supplementary.
The angles. The diagonals.
Yeah.
Okay. You're sort of on the right track. 1 is the opposite sides are congruent. So you can write those values on either. Okay. That's the 1 by definition, opposite sides are parallel. But 2, the second property you should have learned in geometry is that opposite sides are congruent. The second thing, or the third thing, is opposite angles are congruent. So if I have this angle theta here, then this would also be theta, and if this would match this, okay? That doesn't help too much with this question. What the other thing you need to know is that the angles, consecutive angles, so one after another as you move around, are supplementary. So let's just say I can find, because it gives me, oh no, it gave me the other one. Sorry, hang on, let me draw that one.
Doesn't C and D, aren't those equal?
No, so they are bisected. So like the one half of D is equal to the other half of D, but they are not equal unless it's a rectangle or a square.
Oh, okay.
Because they could be, think about it, like it could be really slanted and then this guy is shorter than this guy.
Okay.
Yeah, but they are bisected. So if you wanted to cut those in half, like if D was only on half, you could cut it in half, that would work. But if this is 122 and the consecutive angles are supplementary, how can I find theta? 180 minus 122. So I'd get 58 for this one. And then inside this parallelogram is really two triangles. So I can use this first triangle. I've got 40 and 25 and the angle between them. So you have side, angle, side there to find diagonal C. And then you can use this bottom triangle. You also have side, angle, side with the 25, the 40, and the angle 58 to find D. So you had to use properties of consecutive angles being supplementary to find both of those angles and opposite sides being congruent to put the value on either side. But then you basically just have two side, angle, side scenarios. So you're going to use law of cosines to find that third side.
Wait, so the 25 is the side of like the triangle slant of that?
Like if you want to use this triangle,
Yeah.
then 25 is one side, 40 is one side, and 58 is the angle between them. It would look like this.
Oh, I'm looking at the other 25.
So I'm looking for this,
Yeah.
right?
Yeah.
Side, angle, side. And then the one on the top, 25, 40, and 122, I'm looking for C. It's still side, angle, side. You just got to separate them out. And the last word problem says, two ships leave port at 9 a.m. One travels at a bearing of blank, 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 north, 53 degrees west, at 10 miles per hour. That's an M. And the other travels at a bearing of 67 degrees south, 67 degrees west, at 67 is here, at 17 miles per hour. Approximately how far apart are they at noon? So two things you got to figure out. One is I have to subtract the bearing angle from 90 to get the angle inside the triangle. So if I did 53 from 90, I get this angle. If I did 67 from 90, I get this angle. That gives me the big angle in between them, right? But the catch, like, hopefully we would have figured that out. The hardest part to me, or not the hardest part, but what's different is it's giving you speed here and not distance, right? But how do I find distance? Distance equals what times what? Rate times time. So my speed is my rate, yes? How would I know the time?
Per hour, so 1? Or
Read the word problem again.
9 a.m.
Till noon. How long have they traveled?
3 hours.
3 hours. So you have to multiply the speed, and it's going to change depending on your question. Multiply the speed times 3 hours in order to get the side lengths, because that would be your distance, okay?